be talking about relative molecular mass and molar mass, even in percentage, how to calculate it. Now let's check on what we have here. Let's calculate the relative molecular mass of limestone, which is given as calcium trioxocarbonate 4. This is the more atomic mass of this calcium, carbon, and oxygen. So how to calculate this? You see, the atomic mass of calcium is 40 and carbon is 12, oxygen is 16. So the formula for limestone is given as CaCO3. So how do you calculate relative molecular mass? Relative molecular mass, which is RMM, is equals to calcium plus carbon plus oxygen 3. Oxygen is 3, so carbon now is 40, so it's bring 40. You can see that calcium is 40, so that is why we have 40 here. Calcium is 40, and that is 40 plus carbon, which is 12, plus oxygen is 16 multiplied by this 3. So you're going to give us 40 plus 12 plus 48. So this is going to give us 100. It doesn't have unit because it's relative molecular mass. So that is how to calculate the relative molecular mass of a substance or a compound. Yes. Now let's go down to how to calculate percentage by mass of relative molecular mass of a substance, or percentage by mass of a substance. So how do we calculate the? Let's look at this. Say calculate the percentage by mass of all the component elements in sodium trioxonitrate. Sodium trioxonitrate, all the component elements. Sodium trioxonitrate is NaNO3. So we should calculate all the components, their percentage by mass of all these components here. That means sodium, nitrogen, and oxygen. We should calculate their percentage by mass. So we should calculate their percentage by mass. So what are we going to do now? We will now first of all check the relative atomic mass of this sodium carbonate. Sodium nitrate, by doing the same thing we did last time from here. So we'll now say that relative molecular mass is equals to, we say that sodium plus nitrogen plus oxygen. So now if you look at the atomic mass of sodium is 23, atomic mass of nitrogen is 14, atomic mass of oxygen is 16. So we'll now apply that. See, sodium is 23, so put 23 here, plus nitrogen is 14, put 14 here, plus oxygen is 16, so 16 times 3, giving us 23 plus 14 plus 48. This is going to give us, this is equivalent to, it's going to give us 85. Going to give us 85. So that is 85. So if you watch very well, you can see that in this sodium nitrate, we have elements. Sodium is there, nitrogen is there, and oxygen. So we should calculate the percentage by mass of each of these things. So sodium is 23. So the percentage by mass is mass of element all over relative molecular mass of the compound times 100. So mass of element, now starting with element sodium first. So sodium N over the molecular mass of this compound is NaNO3 times 100. So sodium is 23. Because sodium is 23, so 23 here over what this one actually gave us. The whole of this gave us was 85. So over 85 times 100. So 23 times 100 divided by 85 is going to give us 27.0%. That is percentage of mass of what? Sodium. That is for sodium. The percentage of mass of sodium. Then you also do the same thing for nitrogen. Nitrogen N over sodium carbonate. So sodium nitrate times 100. So also nitrogen is 14 over, and that's 14 over 85 times 100 is going to give us 14 times 100 divided by 85 is going to give us 16.5%. So the last one is oxygen. Oxygen is 3 molecules, 3 atoms of oxygen is there, 3 atoms. So divided by the sodium nitrate times 100. So you're going to give us 40. So you're going to give us 16 times 3 because nitrogen, so oxygen is already 3. So the molar mass of oxygen, the molar mass of oxygen is 16. So 16 times this 3 that is here. This 16 multiplied by the 3. So oxygen is 16 times this 3 divided by what we have been doing before, 85. 85 is gotten from here divided by 85 times 100 again. We're going to give us 48 times 100 divided by 85, which is going to give us 56.5%. So that's how to calculate percentage by mass of all these substances or elements. Thank you, and God bless you. Remain blessed. Follow up and follow my steps accordingly.